Hello, grade 11s, and I hope you're doing well. Thank you so much for the great turnout at PTHS on Saturday. And yeah, welcome to MV Tutors. I'm Tilo, and I'll be looking at the questions we couldn't get to. All right, so I'm going to go straight to question 7. But if there are some of you who didn't really understand question 1, please do drop a comment down below, and then I'll make it a point to go back to it and explain it to you. Okay, so without wasting any time, let us go to question 7. A function. I know functions can be a bit of a tricky one for you, so let's get to it. Okay, so let me just change the color of my pen and let's do it. So it says the graphs of f of x and g of x are sketched below. We can see f of x is the smiley face parabola and g of x is the straight line, okay, with a positive gradient. Now it says the x-intercepts of f are 1 as well as 3. And then the y-intercept is 4. Point D is the turning point of f. The x-intercept of g is at -8. And the graphs of f and g intersect at points K. You can see K over here, and our y-intercept. Okay, so we can see what's going on there. Now let's get to the questions. So 7.1, for 3 marks, it says determine the equation of f in the form of y is equal to ax squared plus bx plus c. Alright guys, so I have done a video on functions, all of them that you need. The straight line, the parabola or quadratic, the hyperbola, as well as the exponential function. Okay, so I'm going to put a link in this video so that you can go to those videos just to understand functions better and ensure that you grab those marks during exams. Okay, so it says 7.1, determine the equation of f in the form of y is equal to ax squared plus bx plus c. Now you need to be aware of the information you've been given. You have been given the intercepts, so if you are given the intercepts, you'll be using this equation over here. Okay, and now we're going to substitute in the x-intercepts, all right, which is 1 and 3. Now we're going to substitute in the y-intercept, which is 0 and 4. Okay, so in the place of y, we put 4. In the place of x, we put 0. All right, then we know that -1 times -3 is just 3. Okay, so we have 3a is equal to 4. Therefore, a is equal to 4 over 3. Now we can go back and rewrite our equation. X minus 1, x minus 3. Okay, and then let's multiply it out. So we have x squared, and then we have minus x minus 3x, which is minus 4x. And we have plus 3. So let's just multiply it in with the value of the a. So it's going to be 4 over 3 x squared minus 16 over 3x plus 4. Please, when you get your answer, don't think, oh my gosh, I have fractions, it must be wrong. No. Don't doubt yourself, okay? Remember what your favorite uncle taught you? That you are a good and perfect gift. Yes. Okay. Now 7.2 says determine the coordinates of point D. Remember, point D is your turning point. And there are various ways of getting the turning point, but let's just go with the easy way, which is basically to say that x, for the x coordinate, by the way, is equal to -b over 2a. Okay. So in our case, what is b? Let me just highlight it. This is B, this is A, and that's C. So B is -16 over 3 divided by 2A, and A is 4 over 3. So at this point, you can just put everything in the calculator. We are trying to save time here, okay? So we have negative, and then we have -16 over 3. Just close that bracket, and then you have 2 times 4 over 3. Okay, and you can see that x is 2. Now we take that 2 and we substitute it in the equation that we found in question 7.1. So there we go. Minus 16 over 3 times 2 plus 4. Again, we're just going to put everything in the calculator. You can calculate it in your mind, but you know, in an exam situation, you could be thinking about a lot of things at the same time, and then you start making stupid mistakes. So let's just stick to putting everything in the calculator just to be certain. Okay, so we have negative 1,33333, which is here, negative 4 over 3. So ultimately, D is basically 2 and negative 4 over 3. Now go look at your graph. You can see that the x value is positive and the y value is negative. So we can move on with confidence. Now 7.3, it says determine the equation of a line P which is perpendicular to G passing through point D. Okay, let me just erase all of this so that we can see clearly. So it has to be perpendicular to G and then it passes through D. I'm just going to draw a random line right now. Okay, so this is not perpendicular to D, this somewhat perpendicular. Okay, but it has to pass through point D. Okay, cool. Now, if you're going to get the equation of a line, what do we need? Okay, to get an equation of a line, we need a point, and they've already told us we have D. So you see how important it is to make sure that in the previous questions you get the right answer because you carry on with it, all right? So D is a point, and then I need a gradient. How will I get a gradient? The fact that they said that this line is perpendicular to G, I will have to go get the equation of the line G. And I know that let me just call this, let me just see, did they give us, oh, they said it's line P. I know that the gradient of line P times the gradient of G has to give me negative 1. Okay, so let me just go and get the gradient of G. Let me get the equation of G. And what do we have there? We have 2 points. We have R, and we also have 0 and 4. Okay, now if I were to try to get the equation, that I would use this equation. So I have the y coordinate of P. Yeah, sorry, I'm just looking strictly at G right now. So I'm going to take R and my y-intercept. Okay, so I will then say the y-coordinate of R minus the y-coordinate of the intercept. Okay, I'm trying to get the gradient over here. There are various ways. If you have, what do you call this? If you have 2 points and you're trying to get the equation of a straight line, you can definitely achieve that. Okay, so I'm just going to go with the many ways, like I said, of getting it. But let's try to get the way of when you're using the gradient, which is exactly what we need at this point. So yeah, let's not even try to get the equation of the line. Let's just get the gradient. So we have the y-coordinate of R minus the y-coordinate of the intercept over the x-coordinate of R minus the x-coordinate of the intercept. And what do we have there? We have 0 minus 4 all over negative 8 minus 0. Okay, so we have negative 4 over negative 8, which is basically going to be positive a half. That is the gradient of G. Okay, now I need to get the gradient of P. So remember that equation? This equation over here. So the gradient of P basically will be negative 1 divided by the gradient of G. What's the gradient of G? It's basically a half. So if I go to my calculator and I say negative 1 divided by a half, it's going to be negative 2. All right, so let's see, is our gradient negative or positive? we can see that it's going down, right? So we are expecting a negative answer. So here we have our gradient then would be -2 for P. Now I'm happy I have a point and I have a gradient, so I can definitely get the equation of line P. Okay, I'm just going to use y is equal to mx plus c, and I'll write it properly, plus c. Then I'll write it properly in terms of P of x, okay, which is our equation of the line. So in the place of y, remember I have a point D, so I'm going to use the y coordinate of D, which is -4/3. And our gradient is -2 in the place of m. In the place of x, I will put 2. And then I can solve for c. Okay, so c will be -4/3 plus, so we have a -2 times 2, which is -4. If I take it to this side, it will be a +4. So there we go. -4/3. -4/3 plus 4. So there we have 8/3. I'm not going to use the decimal form, I'll just leave it in a fraction form. Okay, so ultimately the equation of P, line P, is equal to -2x, because our gradient is -2, right? -2x plus 8/3, which is our y-intercept, which is C. Okay, so far so good. Now 7.4. Calculate the size of KRO. So we want the angle of R. If we're going to look at, let's just highlight it, KRO. So basically we're looking for this value over here, theta. And guys, with maths, please do not forget things, or don't exclusively think paper 2 doesn't feature itself in paper 1. Now remember this equation, if you're looking for the gradient of equation G, it can also be equal to tan theta. That's to do with the inclination of a line. Okay, that's something you would do in paper 2 in the analytical geometry. Okay, inclination of a line. So there we go. Do we have the gradient of G? Absolutely. We did look at it. Okay, so let me write this in terms of theta. So tan theta is equal to the gradient of G. Theta will be the arctan of the gradient of G. What was the gradient of G again? We worked it out. It was basically a half. Okay, so basically arctan half. What is that equal to? Shift tan 0,5. And that is, I'm going to round it up to 2 decimal places. So we have 26,57 degrees. Okay. And that's basically R. Let me just write it as they asked for it. So that's basically KR. Oh, why do I like putting P? KRO. Oh, they did say correct to 2 decimal places. Now 7.5, it says determine the coordinates of point K. Oh, there it is. So K is the intersection of your 2 lines. All right, so let's go get the value then of, or rather the line of G. Okay, so G, we basically have the gradient, and we also have a point. So again, we can use y is equal to mx plus c. So we can use our point, -8 and 0 again. So in the place of y, we have 0. Our gradient there was +2. In the place of x, we have -8 plus c. So basically c is 2 times -8, which is -16. Take it to the other side is +16. And does that make sense for our... No, it doesn't make sense. Actually, in this equation over here, no, I'm doing something wrong. We should be getting 4, not 16. Okay, what did I do wrong over here? Oh snap, I'm using the wrong gradient. Yeah, I know we should be getting 4 because our y-intercept is 4. Okay, my bad guys, sorry about that. Again, let's use the point R, okay, which is -8 and 0, and then let's use our gradient M, G, which is a half. Where did I, yeah, wait again, sorry about that. So our gradient is basically a half, not 2. Okay, yeah, silly mistake. Okay, now let's get back to getting the equation of the line. Actually, I don't even need to get the equation of the line. I know what the y-intercept is. It's 4. So C should be 4, but let's do it the way I had originally planned. So we have a half, and you have -8 plus C. So negative a half, so half times -8 is -4. We take -4 to the other side, we get that C is 4, as expected. All right, so we get half x plus 4. We didn't really need to get the equation of the line. You know what the intercept is, and you know what the gradient is. You should have just plugged it in. I should have just plugged it in. So that's basically g of x. Now getting back to the question at hand, they want the coordinates of the point K, and I said at point K, that's where f is equal to g. What is the equation of f? If you remember, yeah, there is the equation of f. We're just gonna copy that and paste. If only it were that easy for you guys. You have to rewrite it. Okay, and then we're gonna write now the equation of g, and we are going to do some mathematics, gymnastics, and solve for x. Whew. I'm gonna bring everything from the right hand side to the left. Okay, so we have 4 over 3 x squared minus 16 over 3x minus a half x. I'm putting the like terms next to each other, plus 4 minus 4 is equal to 0. Okay, so I have 4 over 3 x squared. So if I have negative 16 over 3 and I subtract a half, I get negative 35 over 6 x, and then the 4's are just going to cancel out. Okay, so I want to multiply everything by 6 because I don't like working with fractions. I'm looking at the biggest value over here between 3 and 6, which is 6. So if I say 4 over 3, okay, 4 over 3 multiplied by 6, I get 8. Okay, so then I'm going to say 8x squared, and then negative 35 over 6 times 6, I'm just going to be left with negative 35. Is there a common factor between 8 and 35? I don't think so, but I'm just going to take out x as a common factor. And then I'm going to be left with 8x minus 35 is equal to 0. So therefore I have x is equal to 0 as one option, or I'm going to have 8x minus 35 is equal to 0. Therefore x would be 35 over 8. Okay. Now we are looking for k, right? So between these two, which one would be k? So here, yes, we have x is equal to 0, but we're looking for k. So we're not going to look, this is not k, okay? This one, x is equal to 35 over 8. That is the x coordinate of k. Did they ask for both? Yeah, they asked for both coordinates. So now that we have x, we can go ahead and calculate for y. And you can choose between the equation of f or the equation of g. I'm definitely going to go with the equation of g, which is a half x plus 4. Remember? We got it there, half x plus 4. And I'm going to just substitute. Let me just say the y value. I'm going to substitute the value of x there. So we have 35 over 8 plus 4. And I'm just going to use the calculator just so that I don't complicate matters for myself. So a half multiplied by 35 over 8 plus 4. Whew, these fractions. I won't lie, if I was in an exam, I would think that maybe something is wrong because these fractions don't look nice. No one likes to work with such fractions. Okay, so our answer then is 99 over 16. That's my y value. So basically k, as we are finalizing this answer, the x value is 35 over 8 and the y value is 99 over 16. You can put it in decimal form to 2 decimal places. I just prefer, in this case, to leave it as a fraction. Okay, now 7.6. Write down the values of x. Ooh, this question, many students struggle with, but it's actually not that bad. Let me show you. So write down the values of x for which f of x is smaller than 0. What you do here, let's erase everything. You are going to look at your function there, f of x. Let's also delete that. This is, the parabola is f of x. So what they're asking there, let me write it down. They want to know where. Remember, f of x is another way of saying y. Okay, so they want to know where the y values of this function are smaller than 0. The y values of f of x, where are they smaller than 0? Okay, so here, above the x-axis, all your y values are positive. Below the x-axis, all your y values are negative. So basically, we are looking at this region over here where the y values are negative. They're smaller than 0. And the question is, which x values are applicable where the y values are less than 0? Okay, so your function, which x values are applicable when y is in the negative region, where y or your function is below the x-axis. That's what this question means. Okay, so like we said, there are our y values below the x-axis. Now, which x values are applicable then? It is in between 1 and 3. Remember here, they just said smaller than 0. They didn't say smaller and equal to 0. So basically, your values are in between 1 and 3. Okay, I hope that makes sense. Okay, in between here, in between 1 and 3, that is where your y values are smaller than 0. Okay, or you could have written it as x is an element of negative 1. You're going to use round brackets here because we're not including the 1 and the 3. So x is an element of 1 to 3. Okay, I hope that makes sense. If it was included, then we'd be talking otherwise. All right, we would put those lines there and then you would have square brackets rather, but it's not included. Okay, now 7.6.2. It says write down the values of x for which f of x over g of x is bigger and equal to 0. Okay. Again, the y values, what it's basically saying, where are the y values of f divided by the y values of g bigger and equal to 0? Please do not be tempted to take g to this other side because they're going to be asked where is f of x bigger and equal to 0, and you might get some of the answers right, but we might miss some of them. So let's rather tackle it this way. Where are the y values of f divided by the y values of g bigger or equal to 0? So here, where will I get a positive answer? Let's start with the bigger than. Bigger than 0 means it's positive. It means if my y values of f is positive and the y values of g are positive, then I will get an answer that is positive. Okay, or if the values of y are negative divided by the y values of g which are negative, negative divided by negative is positive, right? So I'll get the positive part. But they said also equal to 0. So another option to look at is if my numerator is 0 and my denominator is any other value, whether positive or negative, it doesn't matter, then I will have an answer that is equal to 0, because 0 divided by any number will be 0. But please, this option, divide by 0, that does not work, okay? That gives you a number close to infinity, whatever infinity is. So you'll get a math error if you divide by 0. So please don't do it. Don't do it. All right, so now let's get back to our graph over there. Okay, so I said we're going to look at where the y values of f are positive and the y values of g are positive. Okay, so you can see from this point on, g is positive. Okay, and also, so from negative infinity, sorry. From negative 8, okay, negative 8 and above, g is positive, okay, and 0. Okay, the y values there. So from negative 8, let me just put it like this. Yeah, so from x is bigger than negative 8, the y values are positive. Okay, and then for f, where is it positive? So it's the y values are positive over this region and also over that region. Okay, so basically that's where x, we go from negative infinity up until we reach 1. All right, at 1, that's where we have 0, so we can include it. Even here we have to include it because we have, yeah, that's where y is 0, and then it starts being positive. So here the x values start from negative infinity and they reach 1. Okay, whenever you have infinity, you can't really have a square brackets because you don't know what infinity is. And also we're starting from 3 all the way to positive infinity, because this goes all the way to positive infinity. That starts all the way from negative infinity. Okay, so that is where we have both g and f positive. So this scenario over here works. Now let's go have a look for a point where we have negative over negative. So we know that we have a negative values for g from negative infinity up until negative 8. Okay, but here we have only negative values for f when x is in between 1, positive 1, sorry, and also 3. So they never really, so we don't have at the same time where y and where g and f are actually negative. Okay, so this one will not be applicable. All right, so that doesn't work. Okay, and then the scenarios where we have 0 over a positive or a negative answer, it's where I have these scenarios there where x is equal to negative 8, y is 0, where x is equal to 1, and where x is equal to 3, y would be 0. Okay, all right, I hope I didn't confuse you with all of this, but yeah, that's basically the working behind it. Now, how do we write our final answer? Where f of x divided by g of x is bigger and equal to 0. Okay, so I need to condense all of this, okay, because we looked at f and g separately. Now let's look at f and g together. All right, so I have, in this case, from negative 8, okay, negative infinity is not applicable. So where x is from negative 8, this is our answer now. Let me just put it there. So from negative 8 all the way until we have 1. Okay, so from negative 8, we're looking at the x values where y is positive for f and g. It's from negative 8 until we get 1. All right? And again from 3 until we get to positive infinity. Okay, so basically I'm going to say x is an element of negative 8. Remember, it's 0 as well, so I need to include it. Up until 1 as well, I need to include it. And then we also have it at positive 3 until we reach positive infinity as well. But infinity is a round bracket. Okay, so that's basically how I would write my answer over there. Okay, and that's 7.6.2. Now 7.7. When the graph of f is shifted 3 units down and 2 units to the right, it forms the graph of h. Ooh, and now they want it in this form. Tricky. So let's go down here. Or up, rather. So here, if we have the turning point, the coordinates, which we did calculate, and I forgot what it is. So what did we get for D? We got 2 and negative 4 over 3. So they're saying we will be shifting this graph 3 units down, which affects y. Okay, so I'm going to have to subtract 3 and 2 units to the right. A shift in the horizontal, if you're going to the right, it will be negative. If you're going to the left, it will be positive. I know it does the negative, it does the opposite. Okay, you would expect it shifting to the right is positive, but it's not. Shifting to the right is negative. All right, so yes, we have 3 units down and 2 units to the right. Okay, so in this case, I have 3 units down, so it'll be minus 4 over 3 minus 3. That's my y values. And then I'm going to go, is it 2 units now? I forgot. 2 units to the right. Okay. Okay, but in this case, if we're looking at it directly at the graph, if this is 2, when we go over to the right, yeah, you're just going to look. Okay, so we have 2 units to the right, so 3 and 4. Okay, so basically we have 4 there. So that's basically our turning point then for h. Let's work out what the y value actually is. If I have negative 4 over 3 minus 3, it's going to be negative 13 over 3. Okay, so then, yeah, let's see how we can write that equation in the form that they wanted. All right, so let's first write what f is. Okay, they want it in this form. So, guys, you're gonna have to probably complete the square at this point, but let's see. We have the value of a. Okay, so if we have a, x minus p squared, maybe we don't have to complete the square, I hope. I mean, how many marks is this? It's 2 marks. No, I don't think we have to complete the square. So we have the value of a that we calculated, right? It was 4 over 3, right? Yes, it was 4 over 3. So once you calculated a, you don't need to calculate it again. So we have 4 over 3. And then x, okay, initially for f, x minus 2 squared. So what I meant with if you're going to the right, you basically have a negative. That's what I meant. You're going to have a negative here. So our answer, you can't have x plus a value. It has to be x minus a value. Okay, if I confused you a bit. So we have x minus 2 plus negative 4 over 3. That's the y value. So we can actually just say negative 4 over 3. Okay, that was f of x. And now h of x says we are shifting it of x minus we're shifting it 2 units to the right. So now instead of 2, we're going to have 4 minus, to indicate that we went to the right, minus 4. And then we're shifting it 3 units down. So from negative 4 over 3, we have negative 13 over 3. And that's basically our equation in that regard. So there we go. And then 7.8. Wow, this was actually a long question. Okay, 7.8. The graph of J. Okay, so the graph of J is A that's looks like the gradient, AX minus 8, is such that it passes through point negative 4, 0. Okay, so it passes our y-intercept. Okay, but it passes the y-intercept of G, but its y-intercept is actually negative 8. No. Let me see. Where does it pass? Oh, no. It passes the x-axis at negative 4, not the y-axis. Okay, so let's just erase that. So it passes the x-axis at negative 4, and its y-intercept is negative 8. So if we go down here, let's say that's negative 8. So basically, that's the graph of J, right? And what do they want? They want the value of A. So in this case, I think it's straightforward. You can just substitute the point that they gave you in order to get A. So in the place of y, we have 0. And in the place of x, we have negative 4. So if I take negative 4a to the left, it will be positive 4a is equal to negative 8. So a, which is the gradient of the line, we are expecting it to be negative because it's going down from left to right. So then we have negative 8 over 4. So therefore a, negative 8 over 4, that's basically going to be negative 2. And that's the value of a. Okay, if you wanted to write down the equation, you can do that, negative 2x minus 8. And then 7.8.2, they say describe the transformation of the graph from G to J. Okay, what was G again? G was a half x. Okay, I need to go check, I forgot. Half x plus 4. Half x plus 4. And then J is negative 2x minus 8. Now we need to describe the transformation. For how many marks? 1 mark. It feels like a lot of things happened over here. So one thing I can tell you just by looking at it, the fact that the gradients are at 90 degrees to one another, they're perpendicular to one another, okay? Because if I say a half times negative 2, I'm going to get negative 1, okay? So basically, g of x is perpendicular to j of x. That's basically what, if for 1 mark, that's where I stop, okay? So what can we say about the transformation though? So they're at 90 degrees to each other. So if j started over there, if j started where g is, okay, and now we're going from this point over here, 4, to negative 4, I would then say, if I look at my translations or my rotations, because it looked like it rotated 90 degrees, but 90 degrees, we're 90 degrees anti-clockwise about the origin. So that's the description I would say. So it's 90 degrees anti-clockwise. Okay. Yeah, so it rotated, let me write that there, rotated 90 degrees anti-clockwise about the origin. And I'm sure at this point you're like, what? How did I know if it's anti-clockwise or clockwise? There are rules to rotation, okay? I would suggest you have a look at them. Look at your 90 degrees rules pertaining to rotation. and also look at 180 degrees. Okay, and how do you just then take a point here, which is 0, 4, and you see if I went from 0, 4 to now minus 4, 0, then that's an anti-clockwise. If it was from 0, 4 to 4, 0, like here, then it would be a clockwise rotation. All right, and that's where we're going to end question 7. I'll send question 5, which is trig, a bit later. Okay, because we did question 5.2 during the session. All right, so you should be okay with that. But like I said, if you want me to do the entire paper, please do comment below. Thank you.